Now that we've gone over some of the tools you're going to need to use to solve colligative property type questions, let's dive into one of the colligative properties. So if we were to see a beaker of water with nothing in it, we would call this a pure solvent, right? Nothing is in our beaker of water yet. Now, what happens when we add solute? Now, our beaker of water is going to look like this, with solute in the beaker. And so the first colligative property that we are going to look at is called vapor pressure lowering. So how does this work? Well, in our pure solvent, we have water molecules that when you pour this water into the beaker, like we saw in the last module, some of these water molecules will start to evaporate. So the IMFs will break and some will start to evaporate into the gas phase above this liquid water. Some will start to condense and equilibrium will be established. So we have an equilibrium vapor pressure for this pure solvent. Now, when we add solute, what happens to the equilibrium vapor pressure? Well, not only do we have water molecules trying to break their IMFs to escape to become a gas, they also have to fight through and navigate through this path of solutes that are blocking them from trying to escape. So these solute particles are acting almost as little barriers for these water molecules to try to escape to become a gas. In turn, less water is going to escape into the gas phase and is going to establish an equilibrium that is lower than the pure solvents. So the equilibrium vapor pressure of water when you add a solute goes down because of those solute particles. Hence why we call this property vapor pressure lowering. So the formula that describes this is called Raoult's law. This will let us know how much our vapor pressure goes down. Raoult's law says the change in vapor pressure, so this is going to be the lowering, so this change is going to be from a higher number to a lower number, is going to be equal to the original vapor pressure times the mole fraction of the solute. So if we have an original vapor pressure of this water, don't know the real value, and we are putting in a certain amount of moles of solute into this beaker, we can take the moles of the solute divided by the total moles, which accounts for the moles of the solute and the moles of the solvent. That will be the mole fraction of our solute. All we have to do is multiply that by the original vapor pressure without the solute in there, and that will tell us the change in vapor pressure. So if our original vapor pressure is, I don't know, 0.5 atmospheres, and we solve for the change is 0.1 atmospheres, that means our new vapor pressure over here after we added the solute will now be 0.4 atmospheres. So that is vapor pressure lowering. That is our first colligative property, and that is Raoult's law that will describe how much our vapor pressure goes down when we add a solute.